Hello everyone, welcome to this session. Many developers have been using Serverless and AWS Lambda for designing their application and deploying to the AWS. So in this session, I'm planning to cover what all the best practices are to use the Lambda. The assumption is that you would have already played with Serverless and Lambda, have basic knowledge on that, as I'm going to cover only the best practices around it. So before jumping to the topic, let's understand what is the agenda. So to give the context, I will be covering first what is serverless and AWS Lambda, and then I will be covering what all the myths are around Lambda while designing the application, and then we'll be covering how to achieve the high availability, concurrency, throttling, minor monitoring, and then we'll be discussing about how to make a balance between the memory and the execution time. Then we'll be talking about the most important subject, cold start versus warm start, and how we can make use of various techniques to reduce the time. Then we'll be talking about what is the security consideration we should be taking, how to test Lambda application, how to plan the green blue deployment, and then in the last I will be sharing some of the tips to the developers. So let's first talk about what is serverless and AWS Lambda. So serverless applications are the ones where you don't need to manage any servers. The platform take care of it for you. You need to only concentrate on the business logic and developing your application. You no need to worry about the operating systems, scaling, patching, and any other activity related to the server management. So any platform and service which is considered to be serverless has to provide the four basic functionality. The first one, no server management. So you don't need to worry about managing, running, installing any software on any server. Second thing is about scaling. It should provide the flexible scaling. You should be able to scale up by adjusting your capacity, and then you should be able to also scale out, and that too also based on the unit of consumption rather than based on the number of servers. So we'll talk about that in detail when we talk about scalability. The third is about having the built-in feature of high availability and fault tolerance. So any serverless application has to have this feature. The fourth one is about you should not be paying any cost for idle runtime. You should be always charged for the application for the usage only. So you no need to worry about pre-provisioning or over-provisioning of your compute and storage resources. So that is about serverless. Now AWS Cloud provides many components which can be part of the serverless architecture, which includes AWS Lambda. It includes all the event sourcing services what it provides like S3, API Gateway, DynamoDB, Kinesis Stream. So we will be concentrating today only AWS Lambda majorly and talk about what all the best practices are there when you use that. Okay, so let's first high level talk about how AWS Lambda works. So AWS Lambda is a service which needs to have a event source. Event source is nothing but a triggering point for a Lambda function to work. So Lambda function is the place where you will be writing your application logic, and the event source will be the triggering point through which you can trigger this function, and then your function code can interact with any of the AWS services it needs to talk, or it can connect to any other public service. Now event source, as I talked about, that it can be either a API gateway which can be used for your microservices REST APIs to call. It can be a dynamic DB data. If you update any record into the DynamoDB, it can trigger the Lambda function and do the logic. It can be any S3 kind of a storage where you put a new file and then you want to process that. So these kind of event sourcing you can put in place. Now let's talk about what all the myths are there about this architecture, about this service. So as we talked about in the basic definition of serverless is that it needs to provide the scalability. But let me clarify that Lambda or any other service cannot provide you the infinitely scalability. So it does not make all the workloads suitable to run on the Lambda. So there is a myth around that you can use Lambda for any workload because it can provide the scalability for unlimited, right? So don't plan all your workloads to be running on Lambda. You have to be very careful. We'll talk about those best practices in further slides. Second one is about security. So AWS always says that security is a mutual agreement. AWS cannot alone make your application secure, but people who design their Lambda application, they think that Lambda is AWS takes care of all the security of the Lambda. It's not. For your information, Lambda runs on a shared VPC in public, which can be shared by many other Lambdas running from your organization or from other organization. So you have to design your application or your system in such a way that it is more secured, cannot be hacked by any other system. The third one is about fault tolerance. So developer thinks that when I deploy Lambda, it is always fault tolerant. I don't have to worry about its availability. If it goes down, I don't have to worry about that because Lambda takes care of it. Yes, that is true that Lambda takes care of it if you configure it correctly, if you configure it to be having a high availability and fault tolerant system. So developers has to consider this while designing their application. The fourth one is about unit testing. So people think that Lambda is running on the AWS cloud, and that's why you cannot unit test the function code. You always have to deploy into the cloud and then you have to run it on the cloud to either do integration testing or your functional testing, but unit testing is not possible. But that is wrong. You still can do the unit testing around Lambda, and we'll talk about it. The most critical part of Lambda is about its startup time, because as we discussed, Lambda will be charging you based on your consumption, based on its usage. So the more it runs, more it will cost you. You have to make your application performing very well. If it runs for unnecessary reason, then it will add up to your bill and it will be really costly. So you have to ensure that your application cold start time and the warm start time has to be considered while choosing your application language, programming languages, the tools, the configuration, what you do. Everything has to be considered while you design your system. So these are the problems or myths developer have, and the consequences are that you will start getting very high bill, or your application will not be running in a secure and in a proper way, that you will end up saying that Lambda is not right fit for me. And that is what the purpose of this session is, to ensure that you understand what is good for Lambda and how you can make best use of the Lambda features to get your application running. Let's talk about how we can achieve the high availability using the Lambda. So there will be always two scenarios in which you will be running Lambda. When you deploy your code in Lambda, by default there will be a Lambda environment in which it will be running. So Lambda generally runs in a VPC only, which is secure, and Lambda AWS Lambda service itself take care of its security, its high availability, and many other things. It will be ensuring that it runs on multiple AZs of that particular region on which this VPC is there. But in what VPC it runs, which region it runs, it is not controllable by the developer. So in first case, when you are using the default Lambda environment, you no need to worry about the high availability because it is being taken care by the Lambda itself. But the second scenario is where you might be requiring a resource from the VPC. So in first scenario, when we talked about, you are able to access DynamoDB and S3, which are available over the internet. But what if your application needs any RDS resource or any EC2 resource, or you might be requiring the Elasticsearch database? Those resources runs under dedicated VPC. So the default VPC where you will be running, it will not have access to those VPC, and there is no provision that you can make that connectivity work. So in those scenarios, you have to deploy your application, your Lambda, under a VPC, dedicated VPC, where you have other resources which you want to access. Now in this scenario, you have to design, or you have to ensure that you get the high availability. So to get the high availability in VPC, you need to ensure that first you select the VPC, in what are the VPC you want to run the Lambda, and then you ensure that you select the multiple subnets in across the availability zones. So here if you see, there are 3 availability zones are available. So ensure that at least you have multiple subnets for your Lambda. Then only you will, if one of the subnet is down, then other subnet can take care of your Lambda invocations and serve the purpose for the caller. The another thing you need to ensure is that the security group also you need to select under the VPC. Right now I am selecting a default group here, but if your application needs access to internet, then ensure that your security group has outbound connection, as well as your VPC should have a NAT gateway, so that you can make the connectivity to the DynamoDB, S3 or any other public cloud service. From the high availability perspective, that you need to ensure that you're selecting the multiple subnets. The another thing you need to ensure is that each subnet has the sufficient IP addresses, because when we invoke any Lambda function, each Lambda execution needs one private IP address. So let's suppose if this subnet you allocated only 250 IP addresses, then you can run only 250 lambda execution as a concurrent. So that limitation you need to understand, that you need to provide the sufficient IP addresses in the particular subnet. Now let's suppose if your one subnet 2A goes down and then you have only this 2C subnet where uh, your lambda will be running. So then in this case you need to ensure that, let's suppose your lambda concurrent execution is 500, then earlier it was divided between the two subnet 250 250. Now all the 500 calls will be coming to only this subnet and it should be able to handle it. So you need to design, you need to cater this IP addresses in case of failure, in case of your subnet goes down. So this is something developers don't understand while designing the application, and they get the availability issue and that cause a business impact. So this is something I wanted to cover to ensure that all the developers understand that. Let's talk about the scalability and concurrency now. So there are two types of scalability we have. One is called vertically and the another one is horizontally. So in Lambda terms, when we talk about the vertical scalability, we need to increase the memory resource for the particular function. Now there is a upper limit in vertical scaling. Lambda does support currently a 3 GB memory as a vertical limit. So you can scale up only up to the 3 GB for a function. If you have a requirement where you need more than 3 GB memory, then you have to split your functionality in multiple Lambda functions and then you can execute it. Now let's talk about the second type of scalability, which is horizontal scalability. Now if your Lambda execution increases and your current container which can have maximum only 3 GB memory cannot handle it, then it is going to automatically spin up other instances to handle the execution load. So in Lambda, the unit of scalability is equivalent to unit of concurrency execution. So the number of concurrent execution you want to do, accordingly the container will be spinned up. But as I mentioned that no service can provide you infinite resources, and the same applies to the Lambda as well. So there are two levels of limit we do have in Lambda. The first one is at account level, which is 1000 per region per second is the concurrency limit. So you cannot run more than 1000 concurrent execution for your Lambda functions. The second limit is function level limit. So function by default uses the unreserved account level concurrency limit. For example, if you have two functions, one function has been defined with 10 as a concurrency limit, then the 990 remaining limit can be used by another function. Now if you can see, if we don't allocate any account level limit, then the function can use up to 990, or if I don't define even the first one, it can take up to 1000 limit. So it is not a good practice to use the unreserved account level limit. because if for any reason the number of concurrent execution has been increased for a particular function which exhausts all the limit, then it can cause the throttling for all the other functions and they will not be able to entertain any request. To avoid this issue, we should always be defining at function level limit. So let me just quickly show you how we can define the concurrency limit. So if you open any Lambda function, you will see this section concurrency, and by default you will see this option enabled. So this will be using the unreserved account concurrency, which is right now the limit is 1000. And as I explained, the best practice is that you should always define your concurrency, how much the maximum concurrent execution you are expecting for your function to handle should be defined here. Now if it breaches that limit, it will cause to have a throttling, and that you have to handle at the function level, which we'll talk about in our next chapter. But for time being, you just remember that there are two level of limits we have in Lambda for concurrency, at account level and at the function level. Now let's take an example. If we are running the Lambda in VPC, now in this case these limits will not apply, because in VPC it will consider the VPC limits for Lambda execution. Now when you invoke any Lambda function in a VPC, the Lambda set up a elastic network interface ENI, which helps to have a communication among all the AWS services in a secure way, and each ENI will be requiring one private IP address. Now each VPC will have a limit how much maximum IP address they can have. So when you are running your Lambda and VPC, you need to calculate your ENI capacity. By default, the network interface limit for a particular region is 350, but you can use this formula to calculate how much capacity you would be needing. So the formula has concurrent executions multiplied by memory in GB divided by 3 GB. Here the concurrent execution means that how much concurrency workload you are expecting. So it means how many invocation per second for your Lambda function you are expecting, and then how much average time your Lambda function takes to execute. The memory in GB is nothing but how much memory your Lambda function would be requiring to execute your logic. So based on this formula, you can calculate how much ENI capacity you would need, and based on that how many IP addresses you would need to allocate in your VPC. There is one more thing you need to consider while you are designing for your concurrency, that if your Lambda is using any other services like DynamoDB or any other database connection in VPC, then how many maximum connection DynamoDB or other DB services can accept. You have to apply auto scaling feature over there. So these are all the points we need to consider while designing our scalability and concurrency around Lambda. Let's move to the next chapter, throttling. So in Lambda we can do the invocation with several ways. So the throttling has to be handled also differently for each type of invocation. Now, as we discussed, when a certain function is not able to handle the request because it has crossed the threshold limits defined of the resources, then the throttling happens. So let's talk about the first invocation type, which is synchronous. So in this case, your API gateway generally makes a call to your Lambda function and to the REST API processing. Now in this case, when the throttling happens, the Lambda will throw a 429 error code, and it will also send the information about the what level of throttling has happened. So the throttling can happen as function level as well as account level, and based on that you need to handle it at the client level. So API gateway would be getting the 429 error, and that will be passed back to the callers. The best practices to handle the throttling for synchronous processes that you create the API keys for the API gateway and give it to your consumers and ask them to pass it as headers. So based on that, you will come to know from which consumer the high volume of requests are coming, and you can easily manage how to respond back on those scenarios. Now let's talk about the second type is asynchronous Lambda invocation. In this case, the Lambda will be able to again throw the error, but it has a inbuilt retry mechanism, so it will retry that, and even if it is not able to make successes call in multiple retry, then we need to define the dead letter queue. If you don't define the dead letter queue, then the event will be discarded and you will lose the data. So the best approach is that you should always define a dead letter queue in asynchronous call process. Whenever the call fails and retry also fails, the message will go and store into the dead letter queue. The dead letter queue can be implemented either using SQS or SNS, and then you have to plan for the retry mechanism to pick up the data again back from those dead letter queue and process it further. So the third type of invocation is the poll based invocation, and in that also we have two subcategories. One is stream based and second one is non-stream based. Now in stream based like Kinesis, where you'll be getting the continuous data from the Kinesis. So Kinesis has a inbuilt retry logic, so it will be keep retrying the failed transaction, failed invocation, and it will be keep trying it until the time data expires. So in Kinesis there is a expiry date for each data, and that is generally up to 7 days. So Kinesis has an inbuilt retry mechanism which it applies. You can customize it also based on your need. The second one, non-stream, is like a SQS based polling invocation. So in this case also, whenever the retry fails, it will put the message back into the queue, and then after the visibility timeout expires, it will retry that until it successfully processes the data or the retention period expires. So this visibility timeout is the period where other consumers might be using the SQS queue. So during that time it will not do the retry. It will do only after this timeout expires and when no other consumer is using that queue. So that is the way Lambda is some type of invocation. It automatically handles the retry and make sure it works. In some scenarios like synchronous, you have to handle it by implementing the retry logic in the client which are calling it. In the Lambda function, if you are using the AWS SDK, that also has a inbuilt retry policy which can be customized. So the default retry policy is also there, which will be keep retrying to make a call when the transaction gets failed. So AWS Lambda provides various ways where you can handle throttling, where you can handle the retry mechanism effectively. So that is all about throttling, how to handle it. Let's move to the next topic, monitoring. So the benefit of deploying application using Lambda is that you no need to worry about monitoring your servers, your operating system, your malwares. You need to concentrate only the monitoring and troubleshooting of your application. So the easiest way of monitoring your application for Lambda is CloudWatch log. CloudWatch log automatically captures all the logs for the application and generate the matrices which you can use to analyze your application. Let's now have a look what different type of matrices CloudWatch provides. So using the CloudWatch, you can see how many invocation for your Lambda function happens. You can even check how much duration the Lambda function has taken. It will tell you the minimum duration or the maximum duration or the average duration as well. You can also see the success rate of your Lambda function execution. It will also tell you how much throttling is happening at your function level. It will also tell you your dead letter queues which you have defined, how many errors have happened in that. So these kind of general matrices are available which you can use to monitor your function and find out the root cause of the problem. But CloudWatch has a limitation that it will tell you only at the function level what is happening, right? So if you see the duration of the function, it will tell you the total duration it has taken for the whole function to execute. But what if you want to know a little more about the downstream systems, downstream resources, how much execution time it has taken by your other AWS resources. So let's suppose if you make a call from Lambda function to S3 to put the object, or you have called to the DynamoDB to create the record in database, how much time S3 or DynamoDB has taken to do that particular job. So that cannot be checked through the CloudWatch, and for that X-ray has been introduced. So this service, what it does is it basically helps you to double click on the Lambda function and then tell you what exactly is happening at different level. So let's look at the service map. So what this service map does is it will tell you when the invocation happens to your Lambda function, this is the Lambda service and this is the function. So this how much time the Lambda service has taken, how much time the Lambda function has taken, and then it has made to one S3 bucket call to retrieve the image, and then it has made the call to the another S3 bucket to put the image over there. Now if you double click on that, it will tell you the traces of that execution what is happening. So let's go to the traces of that. So here if we come, now if you see, this is the whole function execution time, which is 342 millisecond it has taken. Now it will go to the next level. It will go to this S3 bucket call where it has taken 110 millisecond to retrieve the object from this bucket Rajesh Lambda function. Now another 198 milliseconds has been taken by the another call to the S3 to put the object to the new bucket Rajesh Lambda function mode. So That way you can know how your each downstream service is behaving, and you can figure out which one is taking more time. As we discussed, CloudWatch logs will automatically capture the logs and put the matrices around it. But for X-ray, you have to enable it manually. How to enable it is that in console, you have to enable this active tracing flag so that it knows that Lambda has access to X-ray to put the logging information over there. The next thing what we have to do is at the code level, when we are initializing any resource, it should be wrapped around that X-ray SDK core. So what we have to do is just import this library and then capture the AWS resources around it, and what are the instances will be initialized with that object will now enable the X-ray logging. So here I have put the AWS object wrapping around with the X-ray SDK core library, and now S3 is object which I am using will always have a X-ray logging enabled, and that's the reason we were able to see the S3 was able to tell us that how much time it is taking to retrieve the object and put the object. Now, one thing we need to keep in mind while enabling the logs for the Lambda, that when you are logging any information in Lambda, it will also add up the your compute time. So we have to be very careful while putting logging information in Lambda, because more the compute time, more it will take the execution time and it will cost you more. What is the best practice is that you enable the logging level through the environment variables. So in environment variables, you can define your log level like this, and in your code you can put the condition if the logging level is debug or if it is error. Based on that you should log the information. So based on that you can control your logging. Okay, what all the information you want to log. So it is good to have logging level as debug or info in your development environment, but in production better to keep it as a error log so that you log only the limited information and it will reduce your execution time. So these are the two monitoring tools has been available by the AWS. That's all for the part 1. Let's take a quick break and then come back to watch the part 2 video to understand the rest of the topics. Thank you.